My name is Chris Smith from Yugabyte, and I'm going to take a look at the database landscape for application development. Obviously, we work in and live in a fully digital, always-on environment. Pretty much every interaction you have with a company or an organization is via some kind of digital channel these days. We have digital natives that are both using applications, but also designing applications and bringing digital native requirements to their work and to their usage. When we talk to technology leaders and we ask them, what's driving their technology landscape, they typically call out, four things. First thing is competitive advantage, time to market, getting new services to market as quickly as possible. Second thing is resilience. In these days of always on, fully digital, systems and services always need to be up and available. Customer retention is an important thing. So that points to speed and performance, and also the ability to scale quickly as users grow. And also, as is always the case, always trying to find ways to reduce the total cost of ownership. And that's why most organizations are looking at microservices architectures and using cloud native techniques to build and improve the application development landscape. But what about the data layer? Why is it that despite these modern application architectures, the data layer is often still supplied by legacy monolithic databases? Well, to understand that, we have to rewind several years, 40 years really, back to the 1990s. Keep in mind that Oracle, Sybase, SQL Server, all these technologies and the companies behind these technologies, in reality, they're 40, 50 years old. The designs that went into those technologies really stemmed from the late 70s and the 80s. And if we wind ourselves back to the 1990s, then these databases were typically being used for internal business applications, payroll systems, accounting systems, those types of things. Very low numbers of users, just limited to specialist users, really. And the reality is that those systems didn't really have to be highly available. Ad hoc maintenance was okay. If the IT organization rang up and said, we need to take the database down or the application layer down, the accounts team would just stop work for a while. It was okay. But in the 2000s, the internet changed everything, in the words of Larry Ellison. Systems and applications became exposed to external users. Thousands of users, maybe hundreds of thousands of users started to access systems that were made available by organizations. In order to respond to that, applications and database servers adopted a vertical kind of scale up strategy. Multiprocessor architectures allowed the machines to become much, much larger. But in order to be able to handle the scale of users, it became important for the systems to be on, more than they were off. It wasn't okay to just take the database down every now and then. So companies adopted a DR and HA strategy, which was predominantly organized around having a second database facility, organizing for the data to be replicated over to the backup or the DR facility. And in the event of a failure, users were moved over or migrated to the secondary or the backup database. As time moved on into the 2010s, we had the advent of the cloud. And if the internet changed everything, then the cloud changed everything even more, really. What started to happen was that organizations moved their application and database infrastructure into the cloud. The first sort of techniques, often described as lift and shift, is really just taking those technology stacks and moving them into the cloud, lock, stock and barrel. This is termed lift and shift because it's not really taking advantage of the cloud native architectures. It's really just, moving data center really. At that time, we also saw organizations trying to take advantage of the new cloud technologies. We saw the advent of the NoSQL environments. So this is really where multiple machines, multiple database nodes would collaborate across those multiple availability zones and regions in order to provide a single unified logical database. This is a hard problem. It's difficult to solve. And perhaps unfortunately, certain shortcuts were taken with the rise of NoSQL. The primary objective at this time was really all about availability. Organizations were struggling to handle the very, very large numbers of users that were coming onto those systems. And the primary objective was to ensure availability. And unfortunately, this was at the cost of consistency. The concept of eventual consistency became dominant in the NoSQL database, which meant that if a data item was written into the NoSQL database, then readers of that very same item at the very same time may or may not see that up-to-date value. And they will eventually, but they may or may not see it instantly. To a large extent, that's fine if you're focused on displaying the number of tweets maybe, or the number of friends, or that type of data. It doesn't really matter if you display 1 million or 1,000,001. It's that you display something that's fairly large is the most important. But when you move to banking systems and transactional systems, obviously it is pretty important that when you pull back a list of transactions or a balance, you do have a consistent and up-to-date value. So another thing that was happening during the 2010s was the rise of Postgres and PostgreSQL. I guess kind of during the 2000s, Postgres got launched as an open source project. And then during the 2010s, there was huge adoption. A really large ecosystem started to gather and organize around the Postgres environment. So as we move into the 2020s, application developers are presented with a choice. Do you want the scalability and high availability of the NoSQL environment, or do you want the transactional integrity of the legacy monolithic relational database environment? But in life, when confronted with choices, we always want the best of all worlds, don't we? And it's this that inspired Yugabyte to build Yugabyte DB. We wanted to enable the sophistication and transactional integrity of the Postgres SQL layer and combine that with the availability and scalability of a NoSQL style database. And that's what we've done. So with Yugabyte, multiple nodes collaborate to deliver a strongly consistent, highly available database. Running a Yugabyte database within a single region or data center across multiple availability zones ensures that you have resilience against any failure within availability zones. If you run the database as a single universe across multiple regions, then you become resilient to any region failure or geographically diverse data center failure. If you need more capacity, you simply scale up by adding nodes into your environments, thus achieving elastic scale. All of this is achieved whilst delivering a proper PostgreSQL front end onto the strongly consistent distributed SQL environment. So moving back to what's driving our technology leaders, time to market and competitive advantage. With Yugabyte, you now have the ability to run your data layer in a microservices containerized environment that can leverage DevOps for rapid deployment, gaining all the flexibility and agility of a DevOps environment. Yugabyte gives you the ability to run distributed environments across multiple availability zones, multiple regions, even multiple clouds, that gives you complete business resilience against any level of failure. Customer retention is achieved by Yugabyte making sure that the database is always available, highly available. It ensures low latency as the database is running in a distributed manner across multiple regions. And as customers are added and the velocity of interactions increases, a Yugabyte database can be easily and rapidly scaled. And then, of course, cost of ownership. Yugabyte is an open source database that allows a lower cost, or achieves a lower cost of operation, lower TCO. And also elastic scaling makes sure that you do not have to deploy more resources than you need at any one time. So really it's these four things: time to market, business resilience, customer retention, lower cost of ownership, that is driving people that are adopting microservices for the application layer to also look at Yugabyte to deliver a cloud native, strongly consistent, transactionally integral database technology for the data layer. Thank you for listening.